Okay, so for this second video, I'm going to show you guys how to use Radiance a little more in depth and just kind of a review of some of the Honeybee tools. I think Mustafa showed you some of this stuff, but kind of a good review for creating the images that we discussed last week in class. So in this particular example, we're going to be doing some rendering in false color images using Radiance. So we have a really basic rendering of a scene. This is nothing special whatsoever. This is just a quick low-res rendering just to show how the process works. And then this image here, which is a false color version of the same rendering, that's using one of the false color tools. And this is basically showing brightness levels throughout a particular scene from a certain viewpoint. So, you might be used to using other rendering engines, and there's quite a number of very good rendering engines out there for Rhino and 3D Studio Max and all that kind of stuff. The reason we use Radiance is, one, because we can get sort of an accurate light level type output, more of an analysis. And the other reason is because it's really still the only light accurate and physically accurate rendering engine out there. Now, there's a couple other ones that are sort of coming into play that'll probably be out soon, but this is sort of, I guess, a more scientific version of those. So for this, we're going to be opening the glare.3dm file, and also opening your the rendering Grasshopper file. Okay, those are both in the Dropbox. So let's just kind of run through what's in this file here. Now this is just a slightly modified version of some of the examples Mustafa has that come with Ladybug and Honeybee. So let's take a look. So the first things that we have here are materials and geometry. Now, we're not referencing any of the geometry from Rhino. This is that particular piece of geometry here, but this has been internalized already. So it's actually already in the Grasshopper file, not in the Rhino file. You'll be using geometry from the Rhino file, so what you're going to do is you're going to simply right-click, say set one brep or set multiple breps to select the geometry and bring it into the Grasshopper tool. Okay, so in this case what we're doing is we're creating material, all right, and we have a text material name, we have a color, and then roughness and specularity. So roughness just gives it, doesn't apply a texture per se, but it reduces sort of the shininess. And the specularity also has to do with shininess. We can go over what these two do in a little more in depth, but they're very similar to how other rendering engines treat the reflection of light. And there is certainly a ton of information on the Radiance website about what you can set these to for different types of materials. Okay, so in this case our rendering has two different material types. Okay, and we're then applying them to two different geometries. So our main piece of geometry has a kind of a brownish material, and then the rest of our context has, I can zoom out here to see what that looks like, has another material applied. Okay, so those feed downstream to other Radiance tools that we'll look at in just a second. The other part of this is the sky definition. So here we have our Honeybee generate standard sky, and to do that we need a weather file. Now you'll have to replace this by right-clicking and setting one file path to wherever your weather file is, for that shore file or the California file. We have month, day, hour that we can set. That's going to be the time of the rendering. And then there's multiple sky types. The sky types are, there's a number of different sort of assumptions for different types of sky. For the moment we're just going to be using type 0, which is sunny with sun. And again, there's some more information in detail that we can look at from the Radiance site that has that info. Okay, more on the analysis recipe, as Mustafa called it. This is really just takes the sky file. We set the image width and height. You notice I have this at pretty low resolution right now because this is just a test image. And we have different parameters for quality of rendering. One is kind of the medium. If we roll over rendering here, yeah, 1 is medium, and then 0 is low, and 2 is high. 2, if you set it to 2, it takes significantly longer, but you can see quite a difference in the quality. Usually I set it to 0 or 1 for the initial image, and then once we can bump up this image width and height, and you don't have to have these both the same, I just have this feeding into both right now, but we can increase that quite a bit, and then also change this to quality too. Okay, it's also an option to back up the images. That's so you don't write over each image. You can kind of look at these things as you modify them. Okay, so then let's look at the analysis. So the analysis is still fairly simple. There's not a whole lot of inputs that we're using right now. We're taking all of those objects, so the geometry and material stuff, bringing that into here where it just flattens it. It just takes all that information, brings in here, and that's all the geometry 3D information. Second input is that analysis recipe, and then there's just a couple true false to basically make this thing run. You can set the number of CPUs that you want, so if you have 8 or 12 CPUs or something like that, you don't have to necessarily use all of them. You know, if you just want to use half, so you can still do other work while this is running, you know, that might be advisable. Or if it's something you're running overnight, you definitely want to set this to all of your CPUs. And then it also has a Radiance file name. Now, this will create a directory in your Ladybug folder, which by default is C users, your name, app data, roaming, Ladybug. In this case, it says my first simulation, so it's dumping everything into these folders. Okay, now I've already run this. I'm not going to run this now because it takes about 20 minutes to run in this particular case. But what I've done is where that result file is, that's basically just the directory of what we call the HDR file, that rendering that's output. So it's not outputting anything now because I have this set to false. Again, I'm not going to run it right now, but what I do have here is I just have a little panel with that file folder link. Okay, now obviously this is going to be different once you run it on yours, but I've just dragged that into this component here, HDR file path. Normally you would have your result file pulled into that input, okay, but since I already ran it, this is like I already cooked the whole thing. I'm just using that saved file, okay? And so what this is doing is this is creating an HDR, a GIF image from the HDR, okay? And so what we're doing is we're outputting that, and then we're using a this image viewer called Embryo. I'm not sure, I believe you guys already have this installed, but if not, again, this is in the Dropbox with all the other install files that I'm going to be sending you a link to. There's an image from Path is what we're using to create that image right in Grasshopper here, so you can see the results kind of instantaneously. So this is our photorealistic rendering, okay? The other thing we can do, though, is create an Honeybee false color image. So again, we just would connect this normally to that result file, but in this case, we're just linking it to file path on the drive that I previously ran. And then again, it's doing the same thing from HDR to GIF, and then we're viewing it. Okay, so we can get these nice false color images. Okay, so I hope that helps you run your simulations for these two types of analyses. Again, you're just going to go ahead and replace your geometry with the types that you want, that you're going to use from your house design, and you're going to go through different months and days of the year to take a look at how the light is actually coming into the building and getting affected by the various shading devices. Okay, and then look for the next. We have one more video that you guys can take a look at shortly.